Hey, welcome back to Tech Ed Kirsch. I'm your host, Professor Kirsch. Today, I'm going to talk to you about how you can harness the power of ChatGPT for hardware design. You know what they say, if you want to design hardware, ask an electrical engineer. And also that phrase, by the way, that doesn't exist, I just made that up. But you would scour the internet, you would scour Google, ask double E's and everything to learn how to design your own hardware. But what if the engineer is not available all the time? What if you can't find exactly what you're looking for on the internet, or it takes too long? That's where ChatGPT comes in. As an electrical and electronics engineer and machine learning researcher, I've been exactly in your shoes. It took me 8 grueling years, of searching for information, searching all over the web, reading books, designing some hardware boards that didn't work, especially not the first time, in order to get where I am today. Can you imagine how much faster that process would have been if I had ChatGPT helping me, especially telling me things that I didn't know Maybe I'd have become an expert in like 2 years, 3 years, maybe 1.5 years, 1 year. So that's why I'm making this video, because if you're getting started in hardware design, or if you're trying to level up your game in hardware and PCB design, then ChatGPT is out, it's all the rage. And this is where I can help you. This is why I made this video. Before we dive into how to use ChatGPT for hardware design though, note that Altium does have their PCB design software available. That's Altium Designer, and it's available in the link in the description below. Okay, now let's get into some component selection. If you're a hardware design engineer, you know how important it is to have all the information you need to select and find your components. That's where Octopart comes in. Octopart is a website that allows you to search for virtually all hardware components online, including capacitors, resistors, op-amps, and more. With Octopart, you can easily find the components you need for your design. But what if you need help with more than just finding components? What if you don't know what parameters to look for finding those components or selecting those components? This is where we enter ChatGPT. ChatGPT is an AI language model that can help you with a wide range of tasks, including hardware design. You may have seen the examples like with artwork, with Midjourney, AI generating quizzes. If you haven't seen that video, check that out. But hardware design engineers can use ChatGPT as well. The thing I like about ChatGPT and hardware design is because you don't have to worry as much anymore about what you don't know. Like normally you wouldn't know that you don't know to check for a specific standard, say IPC 2152 for trace width versus IPC 2221 for the updated trace widths. You wouldn't know that unless you did internet research or know that standards were super important. But now you've got ChatGPT at the tip of your hands for free. Just ask ChatGPT and it'll help you with your component research, what to think about when selecting components, and on the fly schematic review, best practices for schematic design, technical questions. Really, the possibilities are endless, especially as I go through and use ChatGPT for my hardware designs, content creation, and things like that. While it can do all these things, these amazing things, and the AI tools that are out there, let's start with a simple example if you haven't used ChatGPT yet. Say you're designing a circuit and you need to find the data sheet for a specific component. All you have to do is ask ChatGPT for the PDF, the data sheet, and it will provide you a link to that data sheet. So let me show you how to do this.
Okay, so let's start with a simple example. Say you're designing a circuit and you need to find the data sheet for a specific component. All you have to do is ask ChatGPT to find the data sheet for you, and it'll provide you with a link to the data sheet. So I'm going to go in here. I'm using the default language model, ChatGPT 3.5, and there's the legacy. I don't use the legacy. All right, as concise as is okay. And then there's also ChatGPT 4. But if you're using the free version, you go with 3.5. And then you'll get ChatGPT Plus for better performance. Okay, so can you find the data sheet for the LM741 operational amplifier? Okay, widely used. Wow, so it even gives you a summary of the operational amplifier. This helps you know if you're actually looking for the right thing. Texas Instruments data sheet, and it automatically names the search as well. So in semiconductor LM datasheet, I'm going to go on here and click on the link and see if this is actually pulling the right information. Good. From Texas Instruments. I can go and click on like sample and buy if I want to. That's good. What about this ON Semi link? More technical documentation. Doesn't take me directly to the part, so and then you can go on Octopart. So I go to octopart.com and then look for the LM741. Then this can search for it as well. And then you have the H and so on. It even warns me to please note that the datasheets may differ slightly depending on the manufacturer. I love that. So let's maybe say you need help with a more complex design consideration. You can ask ChatGPT for guidance on PCB layout guidelines, EMI, EMC considerations, or thermal management. So let me ask ChatGPT a question. Can you provide some guidance on PCB layout guidelines for power management circuits, for instance? Right? So normally I would hit Reddit. I would, ask people, ask experts at Reddit, which I would still do, right? Because you can't replace experts or anything. But I can ask ChatGPT and see what it has to say. So it says, keep the power and input traces short and wide to minimize resistance and inductance. Yep, that's correct. Use the lowest possible resistance path between components to minimize voltage drop. That is true, especially for power. It's interesting that it chose the word resistance as opposed to the word impedance, which comes out to the same thing. But the impedances, the reactances and susceptances are so low for low speed situations that resistance dominates. But yeah, place power components such as regulators, MOSFETs, and diodes and capacitors as close as possible to each other to reduce loop area and minimize EMI. Very nice. Point number 3, separate digital and analog grounds. Good. It says to connect them at a single point, usually the power source or regulator, and use a low impedance ground. Wow, okay, that's really good. Add decoupling capacitors between the power and ground pins. Yes. Place them as close as possible to the IC to suppress high frequency. Very good. Thermal mitigation strategy. Add thermal vias and heat sinks as needed to improve heat dissipation. Okay. Doesn't really give you the full details on that, so you have to kind of dig into that and do your own research or ask it and see what it says and do your own research anyway. Avoid crossing high current traces over sensitive signal traces. Yep, see. Use a guard trace or ground plane to shield the sensitive traces. Very nice. You want correct trace width, copper thickness to handle current load, and then test and verify design using a prototype board. Very good. So it gives you these general guidelines, and that's really powerful. Now, how you actually do it, that's where you'd consult an expert, read books, go through trial and error, and you do that.
Well, that's it for today's episode of Tech Ed Kirsch. I hope you enjoyed learning how you can harness the power of ChatGPT for hardware design. If you have any questions or comments, feel free to leave them in the comment section below. And don't forget to subscribe to this channel for more exciting technology content. See you in the next video.